And there you go. Okay. For two events, A and B, the probability of A is 0.4 and the probability of B is 0.5. The probability of their union, so either this or this, everything together with no repeats, is 0.7. So we're going to follow what we know about let's make a diagram. So we'll make this out of 10. Here, this is what we're going to do. We're going to make a Venn diagram to represent the situation. Here is A and here is B. There is a total of 10 because probability of A will be 4. Probability of B will be 5. If its probability of A is 0.4, that means that we did 4 over 10. So then that means that in just the A bubble, there is 4. And in just the B bubble, there is 5. The whole B bubble is 5. Whole A bubble is 4. If there's a total of 10, that means that we're missing 1. So that right there tells me that there's one person or one thing that's happening outside of this event. And then that means that there's a total of, oh wait, nope. I lied, because we don't know how much is overlapping between 4 and 5. So we first need to deal with the probability of the union of everything. So the union of everything is everything going into a bowl, which is 7 out of 10. So if there's 7 out of 10, which is your entire Venn diagram is 7 out of 10, that means that there's 3 out of 10 that are outside of the Venn diagram. So I made the mistake of adding 4 and 5 together, but I don't know what is in that intersection. I don't know what's shared between the two bubbles. So that was a mistake. So instead, what we should do is focus on the union of A and B, because that's the entire thing together, which tells us that there are 3 events or 3 whatevers that are not happening inside of this Venn diagram. So then out of the total of 10, if I were to think of the A bubble, as being 4 out of the 7 remaining, then that means that I would have to take 7, subtract 4. There are 3 who are in that section versus, again, going and blocking out B. B is 5, which means that 2, taking 7 and subtracting 5, 2 should be here, which means it adds up that this should be 2 in here. So what I did is, since I saw that the probabilities are nice, easy numbers, 10 seemed like an easy number to choose as our total. And then I dealt with these not as percentages or as decimals, but rather as whole objects, and then created my Venn diagram using that. The probability of A means that your entire bubble is A, and it's just a different way of writing what we were talking about up above. So what is the probability of the intersection between those two? Well, the intersection is what's in the middle, which is 2 out of 10. Dividing it out would be 0.2. The probability of not A apostrophe is not A, so you have to add up everything that's outside of the bubble of A, which is the 3 that's inside of the B, as well as the 3 that's outside of everything. So adding those two together, we get 6. Dividing it by 10 is 0.6. The intersection of the probability of not A and not B. So what is shared between the probability of not A and not B? The only thing that is both or neither A nor B is this 3 out here. Everything else is one of those two. So the intersection that's neither of those is just going to be 3 out of 10. So 0.3. Probability of A, remember that straight line down is given B. So probability of A given B, given means this is where we start from. We start from the B. So that's that's 5. And then probability of A given that we're in that bubble is 2. So that's 0.4. And there you go. That last one was pretty tricky. I'll try and find some practice on like IXL practice for you guys to do something that's similar to that. But besides that, you're good to go.